some of the slides that I'm using are in this book here. And they have been prepared by Sophie Stern, who was an employee at Renault when they implemented that. And I helped them in their implementation to kickstart their project. At Renault, the main design team at Renault have a hardware group and a software group. They prepare the specification. They don't build neither the hardware parts of the cars nor the software part. They subcontract the software to software suppliers across the world and subcontract the hardware parts to hardware suppliers across the world. And Renault then integrates everything. So they prepare their software specification and they give that to software contractors. However, in cars, as has been mentioned, software becomes more important and more expensive, and Renault was looking for a way to control and manage the software suppliers in terms of cost. Because it was a major concern, and this is why they got into implementing Cosmic. And some did not expect that everything would be on their own, but they would expect that they would agree to have projects across a reasonable range of the estimation model. This is one example that Renault provided to us of the benefit of the estimation model and then negotiation. And they told me that within the first year of the implementation, they saved millions and millions of dollars. So in a single year, the measurement program paid by itself by quite a lot. And of course, in subsequent years, of course. Another thing that Renault did is automation, because they have every fall hundreds of software projects to measure and estimate within a couple of weeks. They recognize up front that they could not measure that automatically, manually, on time for budget. The budget time is always a crisis time. So they look at automation. Their requirements are into MATLAB Simulink, which is a graphical representation. They prepare the specs of the software using the same approach as they prepare the specs for the hardware. So the MATLAB Simulink model was mapped to the Cosmic model. One of my PhD students helped them to design the automation, and they were very concerned about accuracy of measurement. So the measurement achieved by the automation is very accurate at every process level, functional process level, and at the detail of each one of them. This is a small case studies in Renault on a set of 76 models of requirements of real-time embedded software. The accuracy level reaches over 89% of accuracy. As a summary, this is software classification is critical knowledge for today and tomorrow. And there is not ample evidence that Cosmic function point allows meaningful benchmarking, early and quick sizing, and estimation with very low variation. So with Cosmic function point, there are standards of measurement to build your data repository, to build your productivity model, to use approximation techniques, and to use that for estimation purposes. And your previous presenter has presented to you a good example of the application of all of those concepts within the governmental organization within your country. And on that, I must say that this organization in your country, I'm very pleased to report to you, is quite advanced. I was very impressed by the previous presentation, as well as by Francisco Valdez's presentation, the use of the concept, information history, marine value management, marine scope management with the Cosmic method. And at this present time, I don't know of any country that is as advanced as that. So you can be very proud of your opinion leaders in software measurement. And I can guarantee you that I will borrow some slides from the previous speaker for my next presentation in the USA as well. And I will be giving presentation to the Chinese government in September. And I will be very pleased to challenge them to implement those concepts as quickly as it has been done by your opinion leaders, technology leaders here in Mexico. So, congratulations to your industry, to your technology leaders in measurement, and as well very proud of Francisco.